Um, Hello anyone watching this video or stream. Uh, this is the first day of me learning systems programming and hopefully the first video of a long streak, hopefully. So the reason why I want to do this is commitment, mainly. I want to make I want to make it embarrassing to quit after a few days or weeks. And if I manage to continue doing this for a month or more, the cost of quitting will be very high that I will be less likely maybe to stop. Um, and also because I cannot study consistently on my own. I have mainly for some health issues. I have severe sleep issues, like in addition to chronic anxiety and pelvic floor dysfunction, which I still didn't cure for the last 3 years. I might, I suspect having also the delayed sleep phase syndrome. That's why I will be probably streaming like in very weird times. And I hope that studying while streaming will help me actually study instead of like wanting to sleep 24/7 and blaming my health. Um, so this was a short story about me. So let's begin. The first, I found this book here, which the author, I think his name is what, Bige's Guide to Network Programming. It's really good because it treats you like you are a beginner, not it's not like a reference for someone who already knows stuff, and it's written in like sometimes it's very funny to read. So now I am now here in this section, page 14, which is talking about some structs which I still didn't explore. Okay. Mhm. It's also It says that it's a recent invention. I remember just like asking AI to give me some like show me some basic TCP server, and they did not even use this one. Maybe because it's not that present in training data. But I think this book is also very old. Anyway, and it's linked list. So it says that this will return a linked list, and the guy would use the first result that worked. Okay, let me try this. Why would it return results that don't also from the village find field can pointer to struct sock other. This is where we start getting into nitty-gritty details of what's inside an IP address structure. So I remember this sock other like is a generic pointer which can take sock other in. I think it's a pointer, right? Yes. So it can take a pointer to sock other in, which is for IPv4, and sock address in 6 for IPv6. And you can like you create that struct, fill it, and then cast it to sock other. And somehow the kernel uh, uses that, knows how to treat it, because the first 2 bytes is the sock address family, which stands for either IPv4 or IPv6. So which one can I definitely connect to 6? Oh, so you put a domain and a port, and does it do a DNS lookup? Yes, IPv6. Oh, yes, yes, network cannot actually reach IPv6. Unless, the passive is my return IPv. Oh. What does null mean? And it knows it's beige. Mm, I think I got it. So using a domain name, you ask the kernel to do a DNS lookup, and it returns a uh, list of IP addresses. Some might work, some might not. Yeah, but if it's all hosts, and this is local hosts. Ah, yes, I'm stupid. Yes, it will listen to all IPv4 interfaces, not because each one separately. Okay, now this struct socket address information for many type of sockets. Unsigned short, safe and so what I understand here, like this place, where is it? Where he passed some hints and results. the hint drops, you have to finish with some filter and get out of info. And okay. Okay. Uh, Here is the family IPv4, IPv6, the ports, the IP address, and here a padding probably. Also, same from expanse stuff and see. Ah, so this one is exactly just this one because this is sock other, it's SA, and this is sock other in, it's same. C can be weird sometimes. Yeah, when you see historical reasons, you will definitely see something that is completely garbage and bad, but it's still there because of compatibility issues. It used to be a union, but now those days seems to be gone. So if you declared inno, so color inno.syn other dot s other reference the 4 byte IP address in network by byte order. Oh. Another 16 port address scope ID. Low information of scope ID fields for the moment. Okay, I'll ignore this. I'm not. Oh. I'm just trying to get as enough information to be able to go here and start writing something. But before that, I want to make sure, like, I just have the concepts like memorized. Then I can go try to hack something in C and like mess with the code and see what can I build. But for now, I don't think the information I have now has any use. So that's why I'm not going to write any code just yet. Until I have enough information, then I maybe try to do something with it. Mhm. Stock other storage. They designed to be large enough to hold both IPv4 and IPv6 structures. See, for some calls, sometimes you don't know in advance if it's going to fill out your struct address. No, I don't really understand this. What does that mean? I mean, uh, isn't stock address just like a generic pointer which will anyway be cast to stockadr n6 or stockadr n? Let's do this. this move. Um, this family indicates which one and is a similar except insects structure has additional two things not missing anything required by in generic restricted IP, but the pointer needs real memory behind it. Mhm. This is very stupid. This is what I'm asking for. Version of in practice, but it's not a proper generic term. Means this is IPv. It was granted. I think I understand. To set the storage is for any local, so not only IPv4 and IPv6, right? If we, I don't even know if there is something other than these two. Okay. This makes sense. VM host Bluetooth, Unix domain sockets. No, this makes sense. Okay. What's important is that you can see the address family in SS family. This is to see if inner. Yeah, I think, yeah. Then you can cast it to struct look other in if you want. Fortunately for you, there is a bunch of functions that allow you to manipulate IP addresses. We need to figure them out by hand and store them in along with the right left shift operator. Push the three. So you have, okay, and you have an IP address. Convert an IP address number and dots notation into either struct in other or a struct in other text. In six other. Depending on whether you specify or not. Let me see this. Address family, source, this is the string, destination. Why is it a void pointer? Okay, because it can be stocked in 6, maybe. No, in 6 address or in address. Here is it, how you use it. My bad. Mhm. Presentation to network. Presentation. Yeah, this is easier to remember. Mhm. Always doing things used a function called init other or another function called other. These are no obsolete and don't work with IPv6. to make sure the result is greater than 0 before using. But if you have a struct in order and you want to print it, init other sterling. So this is four bytes. So maybe not four because they need the null character. No, I'm stupid. It's not four because it's like a human readable string. Mm. This function only works with numeric IP addresses. They won't do any name server DNS lookup. No host name. Lots of places have a firewall that hides the network from the rest of the world with their own protection, and oftentimes the firewall translates internal IP address to external. Not everyone else in the world knows if address is using the process called network address translation. I think this is how the routers work, right? Yeah, I mean, this stuff is was already covered in my networking class. That's why um, I just skipped it. But I think it's yeah, it's talking about it for like in 2 or 3 paragraphs is not giving it the time it needs. Patient, of course, needs movement. Okay, finally we are on something practical. We are going into Unix system calls and other library calls that allow you to access the network functionality of a Unix box. For any box that supports the socket API, for that matter, the BSD, Windows, Linux, Mac, whatever. When you call one of these functions, the kernel takes over and does the work for you automatically. Yeah, one of the surprising realization that I made in the recent few months is that most of the time where you are programming, like doing low level programming, where you are supposed to do everything by hand, you technically not doing everything by hand, you just ask the kernel to do everything for you. It's just um, it's just like you have to tell the kernel exactly what to do, but it still does a lot of the work, the tedious work for you. Okay, so let's talk about here. is where is what order to call these things. The place mapping is stuck around here is what order to call these things in. In that, the man pages are no use, as you've probably discovered. Nope, I still didn't. Well, to help with this difficult situation, I've tried to lay out the system calls in the following section exactly in the same order. You need to call them in your program. That, coupled with a few pieces of sample code here and there, some milk and cookies, which I fear you will have to supply yourself. Thank you, Beach. And some rose guts and courage. We'll be beaming data around the internet like the son of, I don't know who's this guy. For waves you may need customers below the not against your error check-in, and very commonly assume that the result from succeed and return a valid entry in the linked list. Both of these situations are properly addressed in the standalone programs, though no use. So use those as a model. Prepare launch. What is the Excel pretty simple? It helps set up the structs you need later. At any bit of history, it's used to be that you use functions to get host by name to do DNS lookups. Get host by name. And then you'd load this information by hand into SOCRN and use that in your calls. As long as it is thankfully, nor it is you can just do something. I mean, I know it's kind of old because it uses like some commands like poll and select, which did exist only before they always exist, but they were used only before 2003 or 4. But then when ePod was created, everyone started using it. So this is like a very old book, maybe. Modern socket API users. The guide is still maintained, updated to be. Oh, that's nice. In these modern times, you now have the function get other info that does all the kinds of good stuff for you, including DNS and service name lookups, and fills out the structs you need besides. Let's take a look. Systypes, node, um, my bad. Like, just an idea, does this domain exist? Example domain. This the domain is for use in documentation example without needing a permission. Avoid use an operation. So it's not available. Like the just someone did someone buy this domain, or is it legally not available for sale? Anyway. Mm, let me ask a question quickly. You own the email address. Why would you need this function? Because it's like a better version of get host by name. So if you already the name, if you already got the host and you don't even have a name, why would you use it? Seriously, the good so just because of convenience. And check from domain, which will doctor this as a single linked list. If it doesn't make a DNS lookup, then it has to be a single node linked list, right? Usually yes, but not guaranteed. You'll typically get one result for those IP service, but you still can multiple results if the hints are broad, especially if it's not specified. Sock type. Socks maybe same IP, same or different. Mm, can you see IP and port combination? No, possible. Possible what? Like servers list on them. One TCP, one UDP. The same machine can have both. Listen on the same time. Oh, really? I thought the same address with the same port, like a combination of another IP and a port, can be listened to by two separate, not two separate, like just one single process. I thought TCP and UDP are just protocols which control byte transmission. that routes those bytes does not know anything about protocol. An IP TCP header UDP header. The IP header contains a field called protocol. You see IP header. Here it is. Protocol 8 bits. Let me test this actually. Let me create some text. Let me create here main.go. Let me server 1, server 2. Here main.go. What to do now? Here I will start. When you first do this, deepest server 1, download image main. Server 2, download image main. Let me close this for a second. Because I don't remember the exact functions to start with TCP or UDP server. Let me see this. Give me the most basic syntax to listing on a port. Let me make it 5.1. H. No. With as a TCP server. Release. If I do this exact same ones here, what? Yes. Port already in use, but here it is listening. What if here is the stable key? If I do UTP, change just yeah. mm, Let's start this again and see if it was going to. Wow, you can really have two processes listing on the same port if they are using different protocols. Let me ask it like if there are other misconceptions or there's some other common mistakes. eh, Make of human for usage be by only one process. If yes, other than different protocol stage the most common used ones. Okay, I will be back soon. All right, we're back, I guess. So we were here when I discovered that multiple processes can listen on the same port. Let me see. IP. Hmm. So if the protocol is different, they can um, I guess from what I read here, different local IP address. These can coexist. I will just ignore this for now. I don't want to clog my brain. Reuse app. I remember this socket option allows multiple processes to listen on the same port, even if they are TCP. And it's like the kernel routes the packets to one random process using the hash, like a hash of the set of destination IP and destination port. I remember. We after all connection and it's like some some kind of like zero downtime deployment. Maybe it's a use case like when you want to shut down the old server and turn on the new server, you make it listen on the same port, then turn off the old one. That way, the new connections will be routed to the new one. But maybe there has to be some kind of procedures to make the old server shut down only after it processes all the existing requests, I guess. Oh no, this is reuse address, not reuse port. No, yes, reuse address is for just to use the same port. This multiple well, the same IP plus port. I will discover this deeply the time I need them, but not now. Okay, let me do this. Mhm. Yeah, like why doesn't Bill Gates info populate hints itself and make the head of the linked list. Why should make this is enough. Input only. Yes, but maybe on the stack. Yeah, but okay. Using it to get res hints useless of what. So it's some design cleanliness. Hints color owner input. Is hint safe to modify? Should be. I think I get it. Just a design choice. Next is parameter service. What? Ah, like HTTP translates to the port number, like HTTP is equivalent to port 80. Mhm. Mm, let's see. I think I do not need this. Um, mm, not usually. Let's see. So this is HTTP. Oh, there is a lot. HTTPS port. Okay, HTTP port 80. So everything is defined here. Like the port 80 gets translated to, like HTTP gets translated to port 80. Okay. So I guess you can add some rules here, I think. And the modify. I don't I don't know I will ever use this, but it's nice to know, I guess. Points to down that you've already filled out with the relevant information. It is a simple call if you are a server who wants to listen on your host's IP address, port 349190. What does this doesn't actually do any listening or network setup. It merely sets up the structure we'll use later. Mhm. Uh, so let me try this. I will try to use get other info and pass here localhost and some I don't know. Oh my god. Well, I can't believe I was talking to myself all the time. Oh my god. First stream kind of problems. I was literally talking to myself. But I mean, that was good. Like when you talk to yourself and explain, trying to explain, like explain to someone, even though no one is watching, makes you understand better and prevents boredom. Maybe this Android app, I must give it the permission to run in the background, even if the phone shuts down, because I did not shut it down manually. Okay, no restriction on apps activity. Anyway, here, just to recap for my zero viewers. So first we use this get other info with the other info struct to get the IP addresses of this localhost port 8080, and it returned uh, IPv4 address, which is 127.0.0.1. Then we set it to IPv6, and it returned like all zeros until the end there is one. And I did it while having like that Python server running. But now that I noticed that it works even without something running in the background. Like it just makes a DNS lookup. And here, since it's localhost, it's just uh, just what? It's just what do you call it? It's just the kernel who does the lookup. Let me see this. This is a server I had before, and the DNS is still in Cloudflare. Here, I don't, I don't even think that port matters here. Segmentation failed. Okay, because here, no address. Wow. Uh, it- God. What? Okay. There is still this one here. Um, Maybe this should work. Yes, I think it is this. The server I had on Microsoft Azure, where I used to host a game. Anyway, um, fine, 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 fine. What's good is so simply returns you a socket descriptor, which you can use or -1 on error. The global variable error is set to the error's value. See error man page for more details. And the quick note on using error image program. Let me see the man pages first. Error. Number of lost error. The file header defines the integer variable error, which is set by system calls on some library functions in the event of an error to indicate what went wrong. Significant only when the return value of the card indicated as an error. -1 for most system calls. A function that succeeds allow is allowed to change error. The value of error is never set to 0 by any system call of library function. For some system calls, this is a valid return on success. In such cases, a successful return can be distinguished from an error return by setting error to 0 before the call. And then, if the call returns a status that indicates that an error may have occurred. I don't think I need to know this right now, so let's skip it. But let's just ask this guy, how does it work? Find what is and also this guy here said something about how is it used in a multi-threaded program. Returning is null and start actual error in error open. Print what you consider string you price then terminal open no such file. Oh, that's nice. That's nice to know. Okay, fine, fine. But what's good is this socket? The answer is that it's really no good by itself, and you need to read on and make more system calls for it to make any sense. Bind. What port am I on? Once you have a socket, you might have to associate that socket with a port in your local machine. Wait, let me do this. Give this back to 8,000. And here to localhost like simulation some real website, because eventually we'll probably make an HTTP request using just TCP. I hope so, because the book seems to be long, so it's probably going to reach that point. Or if it doesn't, it will give us enough information about it. Um, what do we do here? Okay. So we have sock other in. Let's create a socket here. Okay, let's do it before this free other info. I will figure out when to free the actual thing. So in socket fd socket out um, domain elf init type, which type? Sock stream. What's the difference between this and this? What? Anyway, and protocol. mm, Let's see. Is this correct? I IP is TCP. Is it default instead of PC0? Yes, it is correct. Okay. So we have a socket. Yeah, we have a socket. Oh, this is actually bad. This dot family. Here dot type, and here res dot uh, pro protocol. Is this what this guy did? Yes, it is. So we bind the sock address other than. Okay, we bind socket fd result dot so AI other. And last one, let's go to AI other line. Okay. Bind. What is return? Integer. Bind. Return value. Or success 0 is return. And error is set to indicate error. Okay. Like it's direct application to what we are doing here. Just error. Okay, error if one bind. Okay. So we did the binding. So if the my address pointer to structure the container about your address, namely port and IP address, and strlen is the length in bytes. Well, that's a bit to absorb in one chunk. Let's have an example that binds the socket to the host program is running on. I don't know how long the stream has been going. Can you see it here? Yes, 2 hours and 48 minutes. Let me see this. Just like this. Mhm. Socket AI family sock type protocol bind AI other line. By using a passive flag, I'm telling the program to bind the IP address. Yes. So put an IP address in for the first argument to get the other info. Bind also returns on error and sets error to the error's value. Lots of old code manually packs instruct sock other in before calling bind. Lots of old code manually packs sock other in before calling bind. Obviously, this is a bit specific, but there is really nothing stopping you from doing the same thing with IPv6, except that using the info is going to be easier generally anyway. Oh, okay, they do not use AI passive. This is going to be easier generally anyway. The old code looks something like this. I mean, it's alright, right? Uh, this one, I think it's host to network short. It's versus the order of the bytes because because Intel processors use Little Indian and networks use Big Indian. Anyway, let me. So we bind this one with this one. We have the result. The result where do you get it? The result is just sock other type. No. Um, you need the address. The rest family, stock type, protocol are all of them can be known upfront. But this AI other, which is stock other, can yes, it can be filled easily. Which uh, no, no, this one here. So there is import, then other, and others is zero. Port here, you set it to the port, reversed, family, and the rest is wait, no, there is family, right? Port, wait, what? It's import, port address zeros. Where is the family? Hmm. Sock other in my address. This is exactly sock other in. Struct. What? And here, even here. Actually, what? Sin family. Here is sin family. And here the address, port, zeros, and what is actually this family? Is it this one? What does even this line mean? Let me do the which this works. I have some shortcuts that I almost never use. Uh, where is the family? I can access it in code, but in actual definition, I cannot see it. Yes. On glibc, that expands roughly to the same argument is a prefix, but plain. By the way, nice. What is it? Nice UI, OpenAI. Anyway, what is this event? Pre-process macro used in glibc to avoid repeating the same multiple socket structs. It's expanded before compilation. Okay, I think I'm not going to try to understand this right now because I'm just learning basic C, not anyway. Mm, let's continue the book. In the book code, you could assign in other in to the S other field you wanted to bind. You assign another in other in. So what's the other? Is a global variable. It's assigned if your structs or other insects. Let me see this. I don't understand what does it mean by IP address, local IP address. If it's just localhost, why don't you just type localhost? It's the same amount of text. Uh, I think 0.0 is easier to run. Is the magic name of the Linux was in C code? It's clearer than what really? This one is clearer? I don't think so. In it other internet address gives us the okay. Self-documenting means bind to all local interfaces. Okay, whatever. Mhm. Another thing to watch out for is calling bind. Don't go underboard with your port numbers. All ports below are reserved unless you are a super user. You can have any port number above that, provided they aren't already being used by another program. Sometimes you might notice you try to rerun a server and bind fails. Uh-huh. Claiming address already in use. What does this mean? Uh, a little bit of a socket that was connected is still hanging around the kernel, and it's hogging the port. You can either wait for it to clear a minute or so, or add code to the program allowing to reuse the port. There are times when you want to be absolutely have to call it. If you are connecting to a remote machine and you don't care what local port is on it, and where you only care about the remote port, you can simply call connect to check to see if the socket is unbound, and it will bind to an unused local port if necessary. Okay. Okay. The what is level? What is it? So it's a good uh, name level. Next one. The level at which the option resides and the name of the option must be specified to manipulate options at the socket API level. Level is specified as sole socket to manipulate options at any other level. The protocol number of the appropriate protocol controlling the supply. For example, to indicate that an option is to be interpreted by the TCP protocol level, we should set protocol number TCP. Okay, I think I get what this means. Anyway, so socket. Yes, and option name. The arguments of the var outline opt name. Where is opt name? Here it is. Of name and any specified options are passed and interpreted to the appropriate protocol module for the interpretation. The include file socket contains definition for socket level options described below. Options at other protocol level vary in format and name. Consult the approach. Hmm. Let me see how did this guy do it. Oh, what? Outline. Socket. FG level of name. option source socket. So this one lets you reuse the same address when you start the server the second time after just shutting it down uh, in a short time. Because what I have read before is that when you shut down a server, the kernel will keep that address or just that port. I don't know why he's there, like reuse address, not use port. But anyway, let's just ask this guy. Wait a little bit. It keeps the port reserved in like waiting or draining mode because there might be some packets waiting to come and still didn't come to the server and might collide with the new server. Like some packets were meant for the old one, but now there are ones coming to the new one. But I have read also that this is no longer an issue because the randomized initial sequence number, the old ones will use some different sequence numbers, and they must fall into the window accepted by the new one. So that's a very small probability of happening, and that's why basically everyone uses this one. This one is weird. I don't really understand what is happening here, but let's see why it's so reviews again. So reviews same address ports. So the address means the combination of the address and port, maybe, and also the protocol. Combination of address, port, protocol, also not just first two rights. Because the protocol is different, it will not be a problem. Okay. Menus, server crash, restart. All sockets still exist. Use port means something stronger. Multiple sockets combined to the exact same IP port extension. This is for multi-process, multi-thread servers. Yes, that's the thing I was talking about previously, but yeah, I'm just sleeping. I'm not focusing well right now. For multi-process, multi-thread servers. Okay. Yes, Morpheus Flex is about the socket address tuple. TCP IP. Yes. Yeah, I'm learning something. It's the protocol also the same thing, but S there is other. Okay, nice. Uh, Right. Right. Uh, enable this option. What? So you have to pass a reference to a number just to tell it? No, it's yes. So you have to pass an address to an integer containing one to tell it enable it, like one enable, one disable, zero maybe disable. Why? This is no special syntax, it's just passing pointer and integer. Because the old API is old and generic. Uh, why not just pass one directly to that sub other? Oh, yeah, this is stupid. Mm, okay. Uh, int is equal to one. This is stupid. Um, this is is out of uh, the reference of this, and here there is this. Then what? One small extra final notable point. There are times when okay, I agree this connects. Let's just pretend for a few minutes that you are a Telnet application. Your user commands you, just like the movie Tron, to get a socket file descriptor. You comply and call socket. Next, the user tells you to connect on port 23, the standard Telnet port. Yo, what do you do now? Lucky for you, the program you are now perusing the section on connect. How to connect to a remote host. So read firstly onward. No time to lose. The connect call is as follows. Connect sock fd sock other int other than. Yeah, I mean if you need sock other to which mm, oh no, you actually don't call it here. Family sock type protocol. Yeah, other. Yes, here. If you pass it here, why do you need to pass it again to this one? Can't just kernel connect it like using the socket FD? Oh no. Maybe the sock address is the one populated with fields of the remote server, not my own server. Wait. Is our friendly neighbor socket file descriptor as returned by socket call. Wait. Let me try to run this one here. Others. So by using bind here, we are this like trying to reserve that port for us. Uh, are trying to reserve that port for us, but it is already used by this one. So bind, we are not trying to connect to the remote address with it, but we are just trying to like it's us who listens, not like the program is the one who listens, not the one trying to connect to the remote one. So this bind here, I will comment it for now because I'm trying to connect to the remote server, which is localhost port 80 here, and see if I'm going to get this HTML. Oh my god. Make a socket. Connect. Socket as usual by subcall. Serve address is struct. Sock other contain the destination port I and IP address. And other LAN is the length in bytes of the server address structure. All information can be gleaned from the result of the get other info, which rocks. Is this starting to make more sense? I can't hear you from here. So I just have to hope that it is. Let's have an example where we make a socket connection to. So this one, we already had this. Connect AI other. Okay, so it's the same one as here. Uh, and here we'll change this for connect. Right? Yes. Again, old school programs filled out their own struct socket in fast connects. You can do that if you want to. See similar notes in bind section above. Be sure to check the return value from connect. It will return -1 on error. And set also if this we didn't call bind. Basically, we don't care about our local number port number. Yes. We only care where we are going. The kernel will choose a port. Okay. Let me also copy this one here. Put uncomment and what did I do? Connect. Okay, listen. Will somebody please come? Time for a change of pace. What if you don't want to connect to other remote host, say just for kicks? That you want to wait for incoming connection and handle them in some way. The process is two steps. First, you listen, then you accept. See below. The listen call is very simple, but requires a bit of explanation. Okay. By for this one. Let me try to do this. Uh, and page F3. Um, get wait. Uh, get um, size of get flags. What flags? I think I remember. Nope. I can just do right here. And I don't, because I don't know what flags to pass, so I'll just skip that for now. Mm, what? Then get like lemon. Uh, yes, it's RN, HTTP. Let me just copy this one here because I don't need to memorize all of that. Like this. And I need to response. Let me make it 10,000 and read socket fd response, and here size of response. And printf response. Let's see if it's going to output back the data argument. Not used by promise. Oh. Okay, let's try to run it because this one is running here. I'm going to send a basic which what does host mean anyway? Host. Yes, you can drop the host like this. Mhm. Okay. Okay. But where is the body? Server simply HTTP, Python, date, content type, etc. But where is the content type? Maybe I should read many times. Yes, I need to. Uh, Let me just try to remove this part here, like this. Mhm. Mhm. Response. DT, like this. Okay, we read and not like this. We read and print all the responses. Let's try again. Try question. What? Test file. It is being outputted many times. Why? Let me just try this. Um, HTML. Yep. But why does it get output like this? Why do I read many times the same uh like the same? Oh, I think I know why. Because if there is nothing to read, because if there is nothing to read, no, I don't think so. Wait, let me just do it twice. No, just once. Read printf. Read printf twice. Yes, twice it worked, but three times it will just print same thing again. It's just not print this, print this. It will just print the HTML. Yes. Why? I don't know. Maybe because on the second read it reads everything, then on the third read it reads nothing. Let me see. Because if it prints, if uh, if on the third one it reads nothing and it doesn't touch the buffer at all, maybe it will not. Maybe the same value that has been on the second read will stay there for the third print and the fourth print and so on. Like here is the second read, the printf. Okay, response. 0. Let's make the first one like this is equal to null character. Uh, 0. Okay. Yes. So the later reads don't read anything. They are just like just watch. They are just watch. They're just the what have been in the buffer on the second read, and they didn't get deleted. I mean, I thought it made sense if read doesn't read anything, it will make the buffer empty. All right. Let me see. Both buff and bytes. Wait. It returns the number read. Okay. Yes, yes, that makes sense. Here is the third read in size G and is equal to this one. If n is equal to 0. Yeah, this is glitched again. Anyway, into yes. Yeah. Okay. Mm, yes, it's 0. Okay. Full. This is so here we have here we are. Okay. Uh, what is it? Printing the address. Yes. S. What? Yeah, this is glitched. Yeah, now it's back again. This is the thing that is bad. And the bad about 7 11 in the latest version. Okay. How long we have been here? 3 hours and a half. Maybe on the 4 hour fourth hour mark I will stop. But anyway, listen. Will somebody call me? Time for a change of pace. Okay, we want someone to connect to us, not the opposite. Socketd is usually socket file descriptor from socket system call. Backlog is the number of connections allowed on the incoming queue. Wait, backlog is okay. What does that mean? Well, incoming connections are going to wait in this queue until you accept them. And this is the limit on how many can queue up Most systems silently limit this number to about 20. You can probably get away with setting it to 5 or 10. Again, per usual listen returns -1 and set earn. I think we will use this one. We'll have a let me do this. Main 2 dots. Okay, put it here because maybe we're going to use this one because this code here connects to a remote server. Uh, this code here connects to a remote server, and this one we are going to make our server accepts connections. Like we are going to use the main 2 program to connect into main 1 program or main program, probably. Just for practice. So socket is the usual socket file descriptor from socket system call. Backlog is the number of connections allowed on the incoming queue. What does that mean? Well, okay, I don't know why I keep reading the same thing I have read, and I don't notice it until the second line or third line. Well, as you can imagine, you need to call bind before we call listen. Yes, obviously. Okay, stop this one here. I don't need it anymore. Connect. We are not going to connect. We are not going to connect. The page also the make file. Make. Yes, this is here. Okay, do this like this. Make will just main.c. No. Let's make this name 1. What? Yeah, make main. Ph main 2. And here main 2. Let's see. Make and make 2. 2 main 2 1 cleaned. And here main. Okay, let's try. I need this Python 3 http.server and let's here make 2. Yes, it works. Make yes, nice. Okay, now I don't need you anymore. So get this. Let's close main 2 and focus on main 1. int error. Mhm. Okay. This one will be uncommented. Inner socket. Okay. So here we bind to the port 8000. Bind listen, then accept. Okay, we will listen. Listen. Socket FD. Let's make it 30. Mhm. Mhm. Listen. And let's make this just leave that in place of in the place of sample code since it's fairly self-explanatory. The code in accept section below is more complete. The really tricky part of this whole shopping is the call accept. Thank you for calling port 3490. Get ready, the accept call is kinda weird. What's going to happen is this. Someone far, far away will try to connect to your machine on the spot. And you are listening on. The connection will be queued up in the accepted, you have to be accepted in the backlog number. No, it's in the backlog queue. You call accept and you tell it to get on the pending connection. To get the pending connection, it will return to you a brand new socket file descriptor to use for the single connection. That's right. Suddenly you have two socket file descriptors for the price of one. I guess the first file descriptor is just for listening, and the second one for communication with that specific client. I think the original is still listening for more new connections. Ah, okay, yes, it is. The call is as follows: accept socket energy, sock other. So, okay. Why? Why do you have this? You are accepting a connection from this one. I guess you can pass here now, so you can use any port to talk with them. No, I don't think so. Listening other will usually be a pointer to locus to a local. This is where the information of the incoming will go. Ah, okay. So it stores the information of the upcoming call because the upcoming connection, TCP connection, will have some like IP address and port. So you need to know the IP address and the port of who is calling you. Yes, other line is a local integer variable that should be set to size of other storage before its address is passed to accept. Accept will not put more memory. Guess what? Accept returns and set Arnav. Bitch, I didn't figure that. Like before, this is a bunch of observed in one chunk. So here is a sample code fragment for your perusal. Perusal. Uh, okay, backlog chain. Sock other storage, their address. Nice. Accept listen. Root of other storage, their other. And I guess we're going to memset it to 0. No, I guess the function does it itself. So other len, other size. Hmm. Wait a little bit. Okay, this other info, stock FD, this is all we done this all of it. Accept. So FD, stock other, their address, other side. It will fill it, okay. Mm-hmm. Len G add their add len. And we do here accept locket fd struct look other restricts it pass their other um, what uh, their yeah, then this one I should pass the reference and I should cast it um, uh, what use type structs of other algorithms pointer type is required. Should I do something like this? Yes. Uh, Wait, it should work like this. I think. Uh, X. Wait, I can surround this using a shortcut. Why it didn't work? Let's here. Type. Maybe ask Mr. AI. It should work. I am casting there. How to choose that fuck out. Then the casted one. I am passing reference which not the problem. You are casting the value, not the pointer. Huh? You convert the assistant parallel column, check the other assistant parallel. That is invalid, useful for nothing here. A cast person is not or not assignable object you can take. Yeah, I know. I did this and it works. But why doesn't this work? A cast expression is not normal assignable. Is it like that's problem? Is it not constant value on our value? Yes. Ah, at least I understand what this is. So get it back to where it was. What? Mm, And let's copy this. Uh, Accept. Okay. Now we accepted it. Now we'll go to this one here. Where is it? Send and receive. Talk to me, baby. These are two functions. These two functions are for communication over stream sockets or connected datagram sockets. If you want to use regular unconnected datagram sockets, you have to use, you need to see the section on send to receiver. Over stream sockets, connected or connected datagrams. If you want to use regular unconnected datagrams, you need to over stream or connected datagrams. This is for datagram that are connected. Like there is a handshake. I guess this one is unconnected, means the packets just get sent with no connection, no nothing. Let me just ask this guy to see if I'm not wrong. Does this mean by good and good is some form of handshake. Wait. I don't know if stateful connection is correct here. Connected does not mean it's like conjugal or stateful function. Okay, just means you call connect. On a UDP socket does store the default peer address in the kernel. Instead of remember the destination address on the receive packet. Allow send receive, possibly report. I see. Does not mean handshake drive. Yes, I don't mean this one. This is just AI being stupid. But yes, it does not have a handshake. It doesn't use handshake. On connected.tcp, just send packet. Okay. You just send it and you can receive any package from wherever you want. But this one you receive only from where you have sent, from only destination you have sent previously. Here is something that might or might not be new to you. These are blocking calls. There is will block until there is some data ready to receive. But what does block mean already? It means your program is going to stop there on the system call until someone use it. The OS techie jargon for stop is the auxiliary sleep. Yes, I might use those terms interchangeably. Send can also block in the stuff you are sending is uh, is all jammed up somehow. But that's rare. We'll revisit this concept later and talk about how to avoid it when you need to. I think for now, the next, like when I finish this book or most of this book, um, duplicate. I will want to write some kind of event loop, something like Redis style event loop. But like for now, like maybe for the next few sessions, I will just be doing the normal thing, like using two threads per socket, one for read, one for write. Maybe they communicate via some maybe not. Um, Let me see. Maybe it's just one thread per connection. Read something, reply, and so on. Yes, maybe. That's my ultimate goal from socket programming is creating an event loop. Maybe I'll name it something other than socket programming, like the chapter, but we'll see. We'll revisit this concept later and talk about how to avoid it when you need to. Read the send call. Is it socket descriptor you want? is the socket descriptor you want to send data to, whether it's the one returned by socket or the another message is a pointer to the data you want to send, and line is line to the data in bytes. Just set flags to 0. See send mail page for more information. Send flags. Uh, uh, and yes. Mhm. And flags. Message confirm. Tell the link layer that the forward progress happened. You get a successful reply from the other side. If the link layer doesn't get this, it will regularly report the neighbor via unicast. I don't get this, and I'm not going to. Don't wait. Let's see that don't wait. Enables no blockage on. If the operation would block, again is returned. This provides similar behavior to setting the own on block flag via formula, but different from message don't wait is a per call operation, whereas on unblock is a setting on the open file description. On the open file description or descriptor, which will affect all threads in the calling process as well as other processes that hold on the file descriptor referring on the same file, open file description. Okay. Message no signal. Don't generate a pipe signal if the pair close the connection. The e-pipe error is still returned. This provides similar behavior to using sig action to ignore sig pipe, but whereas Mr. Ignore signal is a per call feature. Ignoring sig pipe sets a process attribute that affects all threads in the process. Oh, okay. Yeah, I think this is easy to understand. Kind of. Uh, Previously, we used only like send write because it ignores flags. It uses some default ones, maybe. Just set flags to 0. Still send map page. Send returns the number of bytes actually sent out. This might be less than the number you told to send. See, sometimes you tell it to send a whole gob of data and it just can't literally fire off as much of the data as it can and trust you to send the rest later. Remember, if the value returned by send doesn't match the value in len, it's up to you to send the rest of the string. Good news is this: if the package is small, less than 1 kilobyte or so, 1K, yeah, kilobytes or kbyte, it will probably manage to send the whole thing in one go. Again, -1 is returned and error. Okay. I will create. Wait, let me see. Into what is that place response? I'm so lazy to do it myself. Okay, response. They will reply. Send, receive, receive, package, FD, response. Let's just put here 0 for now. Size. Also, response. Send them aspects. It's like from okay. There, that was easy, wasn't it? You know now. You can now pass data back and forth on stream sockets. We are a Unix network programmer. Let me see this here. Close, get peer name, get host name, client server background. Oh my god, this is cool. A simple stream client. Yeah, this will be a grind. Broadcast pairs. Hello world. Get host by name, get other host for address. This is duplicated. Anyway, let me try to communicate between my two servers. If this is can return 0, this can mean only one thing. The remote site has closed the connection on you and uh, return. Okay. Let me do this. Let me do this. While put this here, like 0 greater than 0. What? Where is the problem here? Expected. Wow. Anyway, uh, accept. No. I will send. the which response you just sent. Which label of function which function of formats are string language which print f would print sm print f. Uh-huh. Okay, I will just delete everything here and sm printf buffer and printf message size dot message and what is here the base message. You just sent s and here a response. Send there the message size of message and here I put the and let me put this. I mean, after connection, we don't need that anymore. Where is connect? Bind. Yes, after binding, we don't need this anymore. Put it here. Yes. Next. There is no this after. Okay. Um, this is the server and this is the client. Not here. The client, I'll put here instead of localhost. Instead of localhost, I'll put this one connects to a server. Yeah, it's localhost. And this one, yes, it should work. Scan f Fetching data in our buffer fields. Elf and wait if into here it is. I will remove everything here. Wait, remove here. Where is his? Put here and here. Um, but okay. So now we have this buffer and we loop infinitely until we hit exit. And if we input something, we put it in the buffer and we write it. Okay. If n is equal to 0, print of client this and like that. Okay, and okay. Let's do this. Make this one is exception. Make two. What? Oh, okay. Hello. What is this one exist? Wait, this one is the server number one. While it does not exist. Why does it exist? It is still running. Wow. It cannot even. Oh, no, such fire. Ah, I know. I know what this is. It is because of the make file. Yes, it is because of the make file which creates this one. Range. Okay. Main range clean. No. To remove Yes, to the like this. Run, run one, run. I know this is the worst makefile you can ever have, but just run two, two. Where main two, run two, R E two. Okay. Now make two. It is still really good. Mm, what? Main run. You know what? I suck at make files, so I'm going to do it all the way. Main, let's see. Main, main. Okay. And main two, let's see. Main two, main. Why does it quit? Why? The problem is this one like exists somehow, but this one, but it like even if it exists, it does not like the server is not shut down. Like it's running in the background. Like PS. Yeah, it is still here. No, I mean I think yes. This is just the current. So the server is not up. But why? Okay. How did this even happen? So here it is. It is still here and still. But if I run the second server, um, I have to write it again. I'm not writing it from scratch. Yeah, it's gone. But this one, this is really weird. Okay, let's see main two. Wait. I'm reading something from okay, here it is. The problem is here. While we receive let me throw in some debugging printfs. Debug one. Put it here. I'm stupid. Okay. Debug 4. Okay, so debug 2 and debug 4. Debug 2. What? Debug 2 and debug 4. So the program exits. Why, when I type something, it's like here this message gets sent. Oh, I'm stupid. Yes, I am completely stupid. Oh my god, this is. Yes, I am completely stupid. I have to read. Oh my god. The buff size of the 0. Because the first file sends the message formatted. Mhm. Ah, and the first one, maybe because this doesn't print, maybe the first one, the first receive. Maybe the first receive. Wait, let me see. Let's try it again. Um, debug 2 and debug 4. Maybe I should use a do while loop here. No, not here. Okay, let me see. Do um, so debug 3 runs. Huh. Error, maybe. Uh, so transport endpoint is not connected. Why? Transport endpoint is not connected. Let me see. Let me rename this n here. This doesn't print, so we are successfully connecting. We are successfully connecting, but the moment wait. Mm, The moment I connect, stops. But why? This, because here I didn't, mm, now let's see. Uh, why it doesn't, Wait, let's see this from the start. We are here for 4.5 hours. So we listen, then accept file descriptor response, and we do this. Actually, I don't want to. Ah, because here I have to receive from their FD, not my own FD. Response and make it here. You just sent. It's like I was trying to connect to myself. Hmm. Let's wait a few minutes until this error goes. Maybe because the server was there, the kernel is still buffering messages. Maybe after 2 minutes it will error out because I have added here some of the okay. If the send doesn't work, it will print an error, but the send doesn't give an error, and maybe that's because of the buffering, like the same reason why you use SO reuse add. We use this because the kernel keeps the connection open for a few minutes just to account for the incoming messages that still didn't come before uh, the closing of the server, and maybe that's why this doesn't error out. I will still wait a little bit here. Why doesn't this error out if no server is listening? Send call may be used only when socket is connected state, so that the intent is recipients no. The only dependency between the flagged argument of the standing socket. No indication of failure to deliver is implicit in send. locally detected errors and cases by return value of negative one. Alright, this is the not want error, right? So here I receive from the HTML message and I send to the MFD he just sent. Okay. Is there a problem here? I have a socket and I use it to connect to. Do I connect? Yes, I'm connecting to the socket FD, which is the socket for the remote server. I connect to it and I send it data and I receive from it. Yeah, this isn't too much errors. Let's try again. Yeah. So this is not working. Why? Here, debug 2 is the one that was printed. We did not even enter here. Wait, let me see the. I have no idea what is going on here. Debug 3 does not print at all, nor debug 4, so it is stuck here, receiving forever. Let me try to send even more data. We know what? I'll just copy everything here and send it. I'll just try to put long text. Try to copy 10,000 characters and put them on the terminal because the buffer is huge. Maybe it's a buffering problem. And the buffer crashed. I mean the terminal. Let me make these buffers smaller. 100. Messages also 100. See where is the problem? Yeah. Yep, there is a problem. There is a big problem. What could it be? Let me. Now I will just ask Mr. GPT. Give me a hint where the problem. Which one did I copy? Main two. Loop order. What? Wait, what? What did I scan F and send? Wait, what? Scan F? Let me first send the user input to the server. What? Scan F? I send it here. Does he have a different code than I have? Scan F? I scan, then I send. Then I receive. Which? Oh my god. What? I still don't see the problem. But you never send user input to the server. You only call, receive, so the client waits for the server, while the server may be waiting for the client. That can deadlock. You never send the user input to the server. I do. What does this line here do? Oh my god, this is stupid. Yes. This is when scanf fails. Oh my god. Finally. Finally. What else forbidden stream? Yes. What a stupid mistake. Hmm. Because of the size of the buffer. Here is 100. Here is just what? The size is 100. Did I put the buffer size 10 somewhere? No. Why did this like it's not the size, it's because of the space. How to make span of ignorance. Let me put here. Okay. Still the same problem. What? Linear space to so the space inside the input. Example, if you want to read the whole line including space, use figures instead. I'll leave this like there, like this. Line disconnected. Receive can return 0. Okay. Now send to send from, receive from. Telegram style. This is all fine, and then I hear you saying, but where does this leave me with a connected datagram sockets? No problemo, amigo. We have just the thing. Since datagram sockets are not connected to a remote host, guess which piece of information we need to get before we send back? Let's write destination address. Oh, okay. Makes sense. Stock FT, const void pointer message, length, flags. Yes, we get this. As you can see, this call is basically the same as the call send, with the addition of two other pieces of information. Two is a pointer to SAR, which will probably be another stock other in or stock other in 6 or stock other storage that you can cast at the last minute, which contains the destination IP address and port. To run an int deep down can simply be size of struct stock other storage. To get your hands down, or to get your hands on the destination address and structure, you probably either get it from get other info or from receive from below, or you'll fill it out by hand. Okay, just like with send and send to returns the number of bytes actually sent, which again might be less than the number of bytes you told it to send. Equally similar, receive from. The synopsis of receive from is int receive from int sockfd sock other from land. Okay, again, this is just like receive from is pointed to local to a local. Why local? Local means on the stack. It will be filled with the IP address and port of the original machine from LAN pointer. Okay. Will contain the length of the address stored from LAN. Will contain the length of the address actually stored in from. Wait, what? Send to will send to an address. Receive from will receive from what? Okay. You will do only bind. because when you bind, you only um, let me copy this. Just copy this one. Uh, wait, where's that? Listen, 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 accept. Oh, okay. Ah, this is when you accept something. So, with the IP of this thing or the network interface. So this right here is usually used with the step because accept already gives you the product of assembly, but frequent you question before sock accept okay UDP flow UDP is connectionless socket bind direct from send to close no listen each UDP packet is independent so every call to receive from can be from a different sender. Oh, so we break just bind this socket if it pause you know and break from you listen on it. Arise for the socket. Also, it may be some state connection key. Just use packets to the bound port. Go to which impact packet and break from was still still not run because it already got a previous packet on the program. we still process image. Now that kernel know when to reject a package, no one is asking for it, and it should buff it. Oh, okay. So once you do bind, it it automatically tells the kernel that some packets are coming from this port. Okay, nice. Why not? Okay, we want to not tie ourselves down so we use the generic socket storage, which we know will be big enough for either. Why isn't socket itself big enough for any address? We even cast down general purpose down to socket. Seems like I don't know. The answer is it just isn't big enough. And I'd guess that changing it at this point would be problematic, so they made a new one. Remember that if you connect a datagram socket and you can then simply use send and receive for all your transactions. The socket itself is still datagram. Let me read it again. Remember, if you connect a datagram socket, you can then simply send and receive for all the transactions. The socket itself is still a datagram socket, and the packet still use UDP, but the socket interface will automatically add the destination and source information for you. You've been sending and receiving data all one day, and you've had it. You are ready to close the connection on your socket descriptor. This is easy. You can just use the elegance to close FT. This will prevent any more reads and writes to the socket. Anyone attempting to read or write the socket on the remote end will receive an error. Just in case you want a little more control, so you can use shutdown function. It allows you to cut off communication in a certain direction or both ways, just like close does. Okay. Um, when we reach here, we'll do something like close uh, there fd and socket fd. Something like this. Um, let's see this. Okay, so I need to set many options like this. I remember there is this SO linger. Um, socket. Sets or gets sorry. When enabled, a close or shutdown will not return until all keyword messages for the socket have been successfully sent, or the linger timeout has been reached. Otherwise, the call returns immediately and the closing is done in the background. And when the socket is closed as part of exit, it always lingers in the background. It always lingers in the background. Okay, but here is the thing. Wait, the message is also here. Um, so the problem with this linger is that it does not always work like expected. Uh, I will talk about this in a little bit, but shutdown, zero success, -1 error. If you design to use shutdown on unconnected execution, just make the socket unavailable for further send or receive calls. Your data can socket. It's important to note that shutdown doesn't actually close the file descriptor. It just changes the usability. To create socket, okay, just close, date, or shutdown. Close, close. Nothing to it. Except to remember that if you're Windows, I don't need to know this because Windows sucks. Gets paid name. Socket is okay. So easy, I almost didn't give it its own section, but here it is anyway. The function gets peer name, it will tell you who is at the other end of the connected stream socket. Okay, the socket is connected stream socket, other pointer to struct. They will hold information about the other side of the connection on other line. Okay, what should be initialized to this one, size of this one. Function returns -1. Once you have their address, you can use into get name info, get host address to print out more information. Now you can't get the origin name. If the computer design in the timer, that is possible. However, is beyond the scope of this agreement. The address of the remote endpoint connected to the peer side, their IP, their box. Range. Okay, already contain the address and for let me reread this again. While the descriptor of the connected stream storage other is the pointer just will hot. Okay. Case of other structure. Okay. Mm. I'm just trying to know what these do, but just to know what exists. I'm not going to use them. This one I know it already. Convert the custom. You can also reverse DNS with just others. Oh, this is cool. Prefer. Guess first name. Easy, even easier than guess paid name. This is the name of the computer. You can the name can then be used by guess other info about to determine the IP address of your local machine. Okay. Yes, local IPs. This means like all the interfaces like Docker 0 interface assigned to you, the router, some virtual interfaces. Yeah, this is a lot of stuff. Is the connection? Okay, it doesn't matter. Client server background. Yeah, this is a very long code. I'm just seeing what is. Oh, okay. Maybe next session will be a little bit tough. Select. Okay, maybe I will stop here. Resume tomorrow. Going now to sleep. No, look at the time now. 8 a.m. I'm going to sleep now. Weirdest sleep schedule ever. Thank you for watching. If anyone is watching, probably not, but